So what we have here is we have an object that is generated by revolving this area around this z-axis. And what we need to do is we need to find the surface area of that object. And we will be doing that by using this equation from Pappus and Guldinus. If you want a video explaining more of this equation and the other theorem of Pappus and Guldinus, you can click on this video link. And I've also got a little bit more of the details explaining these variables written out down in the description. You can check that out. And if you find this video helpful, hit that like button and please subscribe. So the first thing we want to do is we want to redraw this area over here. We're going to set up our axis. We're going to add a y-axis here. We still have our z-axis, which is our axis of rotation. And then we're going to redraw this area we have, and that way we can understand what's going on a little bit better here. So this equation for our surface area from Pappus and Guldinus is the theta, which is the angle of rotation. In this case, we're going all the way around, so it's going to be 2 pi because it is measured in radians. And then we have the sum of the perpendicular distances of each component of the part, the distance between the axis of rotation and the centroid of each component part, multiplied by the length of that line. And in this case, the component parts are going to be each of these line segments. So we have one here and one here and one here and one here. And I'm just going to label here the centroids of each one of those lines. It's just going to be right in the middle of that line segment, since these are all straight. And it is going to lie directly on the line. And we're going to label these A, B, C, and D. That way we can keep track of them. And so these dots are their centroids, and we need to find R tilde, which is the perpendicular distance between our z-axis and them, the dots, the centroids. And we are going to list all that right out here. So we have A, and we're going to find its R tilde, and it's L, the length of the line. So A, it's pretty simple. It is just going to be 1.5 meters away from that. We're already given that. So R tilde is 1.5 for A. For L is going to be 1.5 plus 1.2. So that'll be 2.7. For B, the R tilde is going to be 1.5 plus half of its width, which is 0.9 divided by 2. So 0.45 plus 1.5 is 1.95. And then its length is 0.9, so 0.9. For C, its centroid is 1.5 plus 0.9, so that is going to be 2.4. And then its length is given to us, it's 1.5. And then D is probably the most complicated one, but you'll realize that the centroid of this for D is in the middle of that line segment, so it's just going to be in the middle of the area. It's going to have the same perpendicular distance between the z-axis and it as B does. So it is also going to be 1.95. And then its distance, or its length, you can find through the Pythagorean theorem. We have the length of this side of the triangle, which is 1.2, and this side is 0.9. And using that, we find that its length is also just 1.5. So now that we have all this information, we can plug it into this equation to find the surface area. So the surface area of this entire object after it is revolved around this area, after it is revolved around the z-axis to create this object. Its surface area is going to be theta, which is 2 pi, because we're going all the way around a full 360 degrees, multiplied by the sum of all these multiplied together, and then we'll add them all up, and that's what I'm going to write right here. And so plugging all this into your calculator, you get that is the surface area of the whole thing is 77.5 square meters. And so this might be helpful, say if you needed to paint this object and you knew how much paint it took to cover a certain square, a certain area, and this would help you to do that. And in fact, I'm going to go over another example problem that does that. You have to find the area of a roof, and it's a little bit more in-depth, it's a little bit more complicated because its lines are modeled by a parabola instead of just straight lines. So if you want to go to that example problem video, you can click on this video link. And I hope you found this video helpful. If you did, hit that like button. If you have any questions or suggestions, leave them down in the comments. I appreciate the feedback. I've also got my website up and going, ghostinengineering.com, and it has all these videos on there plus a little bit more stuff, and checking that out helps me a lot. So if you're new to this channel, my name is Preston Palmer with Student Engineering, and my goal is to help other engineering students like me better understand engineering. So if you found this video helpful, hit that like button and please subscribe.